Hello guys, welcome once more to another live session on the Mathematics Academy for Africa YouTube channel. So if you're joining us for the first time, make sure you like the video, you share the live session with your friends, and you also subscribe to the channel. Don't forget to turn on your notifications so that whenever subsequent live sessions are uploaded, you'll be notified to come and watch. So this lesson I'm going to be doing today is specifically for maths with statistics students and further math students. So we are going to be looking at continuous random variables. Okay, so for you to have a better experience on this live session, the comment section is open for you to post your worry whenever it arises during the explanations. You also have the ability of increasing your resolution power, okay, because the video might not really, it might be blurred in your device. So try to increase your resolution power maybe to 720 or 360 depending on which one is best for your device, so that you can easily see the video clearly. Okay, so in our last revision session in our last live revision session, we were looking at oblique impacts, and I was very happy that so many of you got to me later on WhatsApp, sending me the solutions to the assignment that I gave. So it actually made me happy knowing that at least what I'm doing is impacting one or two persons out there. So same thing is going to happen in this topic. At the end of this topic, I'm going to give out assignments, and you can get to me via the number here displayed to you on WhatsApp and submit your assignment so that I can go through and see if you are in the right path or you have some things to clarify. Okay, so we have a course outline. Okay, we have to look at mathematical definition of probability density function for a continuous random variable. We need to determine the mean, the variance, and the standard deviation of a continuous random variable. We are going to exercise the properties of the mean and the variance of a continuous random variable. We are going to determine the mode, the median, the upper quartile and the lower quartile of a continuous random variable. Then we look at how to get a cumulative distribution function when given the probability density function, and vice versa, which means if I give you the cumulative distribution function, we'll also see how to get the probability density function. And lastly, we are going to solve some practice examination questions in further math and in maths with statistics paper 3. Then I'm going to introduce the next lesson, which is discrete random variables, and I'm going to give you guys a date and a time so that you don't forget. Alright, so basically the way I prepared the lesson, all the examples I'm going to be solving are past GCE questions. Some questions from math to statistics and some questions from further math. You realize that they have a 99% resemblance. Okay, that's why it's important that if you have a friend who offers further maths and is not here, just share the live session with your friend, or a friend who offers math to statistics and is not here, just share the live session with your friend, because I'm going to explain in such a way that it benefits both parties, both further math students and math statistics students. Alright, so the first thing on board we have is a mathematical definition of the probability density function of a continuous random variable. So the definition is that if f of x is a probability density function of a continuous random variable x defined on the interval a to b, or on the open interval a to b, or maybe just on an interval I, okay, because maybe there could be many intervals, then the integral from a to b of f of x must always be equal to 1. So that is the definition of the probability density function of a continuous random variable. So if we call you the probability density function of a continuous random variable, then your integral over the interval where that variable is defined must always be equal to 1. Now note that if I ask you to find the probability of x lying between two values, maybe say alpha and beta, the result is just the integral from the lower bound alpha to the upper bound beta of f of x dx. Let's go straight away to applying this definition. Like how do we apply with an example? So this is June 2024 for the math paper 3. I think it was question 8b if I can remember well. So I just copied part of the equation, which is the part that interests us on our first definition. So the question said that a continuous function g of x is defined by this. Okay, so let us interpret this function. So g of x is equal to 3 on 4 into 2x minus x squared when x is in the interval 0 to 2, and then it is equal to 0 otherwise. Now this otherwise means that for any value, for any other interval that x belongs to, the g of x is always equal to 0. Okay, that's the meaning of this otherwise, which means that this interval is the same as when x is between 0 and 2, which means that if x is not between 0 and 2, that is, if maybe x is bigger than 2 or x is less than 0, g of x is always equal to 0. So that's just the interpretation of this function. So we are asked to show that g of x is the probability density function of a continuous random variable x. So by our according to the definition we have, we know that if you are a probability density function of a continuous random variable, then your integral must be equal to 1 over the interval where the variable is defined. So here I'm going to write a statement: g of x is a continuous, so g of x is a continuous g of x is a probability density function. So g of x is a probability density function of a continuous random variable. Okay, so g of x is the probability density function of a continuous random variable if and only if, so it's very important that we write down what we need to show, if and only if the integral, now g of x is defined over the interval 0 to 2. So the integral from 0 to 2 of g of x with respect to x must be equal to 1. Okay, so that's the definition. Then after writing this, I now have to find the integral. If the answer gives me 1, then I'm certain that yes, g of x is the probability density function of a continuous random variable. Okay, let me write x. Okay, so let us find the integral. So what is the integral from 0 to 2 of g of x? This is just equal to the integral from 0 to 2. Now we know that in the interval 0 to 2, our g of x is equal to everything here. Okay, so we are just going to integrate and fit the bounds. So this is g of x over that interval. So since 3 on 4 is a constant, we put it out of the integral. So we have 3 on 4. Then we are going to be left with the integral from 0 to 2 of 2x minus x squared dx. Okay, so this gives us 3 divided by 4. Now we are going to integrate 2x and we are going to integrate x squared separately. Then we fit the limits of integration and simplify. If the answer gives us, so if I integrate 2x, we have 2x squared divided by 2. Okay, if I integrate x squared, I get x cubed divided by 3 from 0 to 1. Sorry, from 0 to 2. Now for those who have not really understood how I integrated, let me just try to give a note. Recall, if I integrate, if I give you the integral of x to the power n with respect to x, what you do is that you take x to the power n plus 1 divided by n plus 1 plus a constant of integration. But if there are limits, we don't add the constant of integration. Okay, so this 2x is the same as 2x raised to the power 1. Okay, so 2 is a constant, so it remains there. If I integrate this x that is here, I get x to the power 1 plus 1, which is x to the power 2, divided by 1 plus 1, which is 2. Then, since this is x squared, you are going to have x to the power 2 plus 1, which is 3, divided by 2 plus 1. So that is the rule I used in integrating this. So this is equal to, now we have 3 over 4. Now this first term just simplifies to x squared, right? Because the 2 cancels. Okay, so if we simplify, what do we have? We have 3 on 4 outside. We are going to have 2 squared because we need to replace 2 here, and then also replace 0 and subtract. But when we replace 0, everything gives us 0, so it just suffices to replace the upper bound. So we are going to have 2 squared minus 2 cubed over 3. So this gives us 3 over 4 into 4 minus 8 over 3. Now 4 minus 8 on 3 is 4 on 3. Okay, so we have 3 over 4 into 4 divided by 3. and 3 on 4 into 4 divided by 3 is equal to 1. Okay, so we have seen that it implies that the integral from 0 to 1, from 0 to 2 of g of x is equal to 1. Therefore, we can conclude that g of x is a probability density function of a continuous random variable x. So that is a proof. Okay, so this was just kind of me trying to use the definition I've given and applying it in an exercise, and luckily for us we had an exercise like this in further maths paper 3, June 2024. Alright, so we are done with our very first objective of today. Now the second objective is we need to determine the mean, the variance, and the standard deviation of a continuous random variable. So the mean, let's begin with the mean. The mean of x is also called the expectancy or the expected value, and it is represented by the symbol mu or e of x. Most of the times we use e of x, showing that it is a mean of x. And what is the definition? E of x is equal to the integral from a to b of x times f of x. This f of x is a probability density function of the continuous random variable x. So here is a definition of the mean. So we are going to integrate, okay, but we are going to multiply the function with x before integrating, and then we integrate on the bounds where the function is defined. So that is a mean. Now let's go to the variance. Let's go to the variance of the random variable. So the variance is represented by sigma squared or just the var of x. Okay, so either we use sigma squared or the var of x, and it is defined by what? E of x squared, it's defined by e of x squared minus e of x all squared. Now what is e of x squared? E of x squared is the integral of x squared times f of x. So since we know that the mean e of x is the integral of x times f of x, what is e of x squared? It is the integral of x squared times f of x. So for me to get the variance, I will first of all need to get e of x squared, which is integrating this. Now this is the mean, so we don't have any problem because we have already seen how to get the mean. Alright, so to get the variance, you must first of all find the mean, then you find e of x squared, then you fit in this formula e of x squared minus e of x all that squared. So there's a difference between e of x squared and e of x order squared. This e of x squared is the mean of the variable x squared, while e of x order squared is just the square of the mean of the variable x. Okay, anyways, you are going to look at the practice exercise later, so let me just try to explain. Now next is standard deviation. By definition, standard deviation is sigma, okay, and is the square root of the variance. Since it is always positive, if we take the square root of sigma squared, we get sigma. Alright, so for us to get the standard deviation, we must find the variance. Then when we get the variance, we just take the square root and it gives us the standard deviation. Now let us look at the properties of mean and variance before we go to an exercise from June 2023, pure maths with statistics paper 3. So I'm going to consider two constants, and then I have my random variable x, which is a continuous random variable. The first property is that the mean of a constant is always that constant. So for example, the mean of 5 is 5, the mean of 8 is 8. Now the variance of a constant is equal to 0. So the variance of any constant is equal to 0. Now the mean of ax plus b is equal to a times the mean of x plus b. Okay, and then the variance of ax plus b is just a squared times the variance of x. So these properties are very important because we are going to be exercising on them very soon. Let's take our second example. Our second example is coming from June 2023, pure maths with statistics paper 3. So it reads, a continuous random variable x has probability density function f defined by this. So again, the interpretation. So the probability density function f of x is equal to this function when x is in the interval 0 to 2, and when x is not in that interval, the probability density function is equal to 0. Okay, now the question says we should find the value of the constant k, the mean of x, and the variance of x. Then there's also a last part of the equation which we are going to do later because we have not yet arrived median. They are just copied all the equations, so there's no even need for me to read it. Okay, So let me just shift it down so that we have enough space to solve. Okay, so we have a continuous random variable and the probability density function has been given to us. Okay, so we need to find the value of the constant k. So we have to use the fact that since x is a continuous random variable, okay, then what happens? The integral of the probability density function of the continuous random variable must be equal to 1. That's the definition. So since x is a continuous random variable and f is the probability density function, then what do we have? We have that the integral from where to where, from 0 to 2, okay, of f of x dx must be equal to 1. Okay, what does this mean? This means that the integral from 0 to 2, what is f of x? This is f of x. So 1/16, I'll start with it first. It's the constant, so I put it out of the integral. Then I'm going to multiply this x with every term here. Okay, so we are going to have the kx squared plus 12x. Then the x must be equal to 1. Be very vigilant as I'm solving. So this means that you see, have your 1 on 16. You see, have your 1 on 16. Now let us integrate. Okay, let us integrate what we have there. If I integrate kx squared from that rule I gave you guys, if you integrate kx squared, you get kx cubed divided by 3. Okay, plus if you integrate 12x, what do you have? You have 12x squared divided by 2. Now we're integrating from 0 to 2 and we're equating to 1. So this means that I'll just multiply both sides by 16. Okay, so I'm going to have here now. Let me first of all simplify. Let me go gradually. So to simplify, we see that 12 on 2 is just 6. So instead of putting 12x squared on 2, I'm going to put 6x squared. Good. This is what we have. Then equal to 1. Now let us start the simplification process. So I first of all multiply both sides by 16. I'll just be left with this left hand side equal to 16. Okay, so I have this left hand side equal to 16. You can see allow the 16 there, no problem. Okay, now let us feed the upper bound. So if I feed the upper bound, which is 2, I'm going to have k over 3 times 2 cube, and 2 cube is 8. Okay, then plus 6 times 2 squared, and 2 squared is 4. Then we equate. When I feed the lower bound, which is 0, I'm going to have 0 here and 0 here, so there will be no need to be subtracting. Then we equate everything to 16. Then we need to find the value of k. So to get the value of k, we'll start by multiplying all through by 3. Okay, so that we will move the denominator. So you are going to have 8k. That if you multiply the left hand side by 3, then you also need to multiply the right hand side by 3. Okay, so multiplying the left hand side by 3, if you multiply the first term by 3, you get 8k. Now this is 24. Yes, 6 times 4 is 24. Now we need to take 3 times 24. So if you take 3 times 24, I think you have 72. But let me just use a calculator to be sure, so that all our answers are going to be 24 times 3 is 72. So you are going to have 8k plus 72 equal to 48. Okay, because 3 times 16 is 48. So from here, I'm going to subtract 72 on both sides of the equation. So you are going to have 8k is equal to 48 minus 72, which is negative 24. So from here, we divide both sides by 8, and what will be k? K will be equal to negative 3. So this is the value of the constant k. Okay, next is what is the mean of x? By the definition, the mean of x is equal to, like we said, it is the integral from 0 to 2 of x times f of x dx. Okay, so this is equal to the integral from 0 to 2 of x times, what is f of x? This is my f of x here. 1/16 is outside. I put the 1/16 outside, and then now this remaining portion is inside. But we need to multiply it by x. Okay, we need to multiply it by x. So this portion is inside. Good. So that is the definition of my mean. So this means that e of x is equal to 1/16 is outside, Now, since we know the value of k already, right, we'll just replace k as -3. Okay. Now, what do we need to do? We need to multiply each term by x and then integrate peacefully. So this is 0 to 2. If we multiply, we are going to have -3x cubed, okay, plus 12x squared dx. So we are going to have 1/16. 1/16. Now let us integrate each term. So if I integrate the first term, let me just fit my bounds from 0 to 2. If I integrate the first term, we have -3x to the power 4 divided by 4. Okay. If you integrate the second term, we have 12x cubed divided by 3. But we know that 12 on 3 is 4. So I'm just going to write 4x cubed. Okay. Then now we need to fit the boundaries. So if we fit the boundaries, we have 1/16. We are going to have -3. We multiply with, it's like, let me just go down there. But I think we'll still need to be checking on it. So let's fit. We have -3. We multiply with 2 raised to the power 4 and we divide the result with 4. Then plus 4, we multiply it with 2 raised to the power 3. Okay. I think with your calculator you can easily get this answer. I'm not going to go further. Okay. Because I don't want the video to be too long. So with your calculator, you're going to simplify this answer and you put your answer as a simplified fraction. Okay, what about the variance? So we know that the variance of x is equal to e of x squared minus e of x all squared. Minus e of x all squared. Now, what is e of x squared? E of x squared is equal to, the integral from 0 to 2. We said it is x squared times f of x dx. Okay, so instead of multiplying my f of x with x, I'll multiply it now with x squared. So I say I have 1/16 outside. I'm just going to change this x here to x squared. Okay, so I'm going to have the same thing, but in the place of x here, I put x squared. Okay, so what does this gives me? In fact, let us just simplify to the end. Yes, let us simplify to the end. Okay, just that I have a calculator here, so I might be taking a little bit of time. Now, 2 to the power 4 is 2 to the power 4 is 16. 16 over 4 is 4. Times 3 is -12. Then plus 2 to the power 3 is 8. 8 times 4 is 32 plus 32. So this gives us, now if you take -12 plus 32, I think you have 20. So you have 20/16. If you simplify, 4 goes up there 5 times and goes down here 4 times. So my mean is equal to 5/4. Therefore, the mean of x is equal to 5 divided by 4. Okay, now let us go to our variance where we are looking for e of x squared. So you have 1/16 outside. Now we are going to be integrating, but I'll make sure that we multiply every term by x squared. Okay, so this x squared distributes itself. Multiplying with this man, you add the powers, is x to the power 4. Multiplying with this man, it becomes x to the power 3 because it was x squared and x. Okay, so you are going to have 1/16. Now let us integrate each term. So you are going to have, if you integrate the first term, you have -3x to the power 5 divided by 5. If you integrate the second term, you have 12x to the power 4 divided by 4. And everything is from 0 to 2. Now we know that 12 on 4 is 3. Okay, so I just have 3x to the power 4. Okay, so from here now, let us see how to simplify. So you are going to have 1/16 into, let's fit. So you have -3, then we multiply it with 2 to the power 5 and divide it by 5. Then plus 3, we multiply it with 2 to the power 4. Okay, when we fit 0, we have 0, so there's no need to fit 0. So you have 1/16. Now what is here? This is -3 multiplied by 32/5. Okay, plus this is 16. Okay, 16 times 3 is 48. All right, 48. So what I'll do is that for me to ease my work, I'll just multiply each term by 16. So if I multiply the first term by 16, that's this term by 16, we have that 32 on 16 is 2. The 2 multiplies with negative 3 to become negative 6, then 5 is still in the denominator. So the first one will be minus 6 over 5 plus. Now 48 times 1 over 16 is 48 over 16, which is 3. Okay, so I think we simplify this. You have 5 times 3, 15, minus 6 is 9. So you are going to have 9 divided by 5. Okay, so that is E of x squared. So my variance, I might have made a mistake. Okay, but make sure you get the explanation, because I don't have a calculator, so I might have made a mistake somewhere. But focus on understanding and also be working so that you compare your answer with mine. Now the variance of x, like we said, is E of x squared minus E of x all squared. So my E of x squared is 9 divided by 5 minus my E of x all squared. My E of x is 5 on 4, so I'm going to have 5 divided by 4 all squared. So this gives me 9 over 5 minus 25 divided by 16. Okay, so the LCM I think is 80. If I take 80 divided by 5 is 16. 16 times 9 is 144 minus 80 divided by 16 is 5. 5 times 25 is 125. So at the end of the day, we are going to have 144 minus 125 is 19. So you are going to have 19 divided by 80. So that is my variance. Now, if maybe the question said find the standard deviation, let me just add. Let me just put D here. Okay. So this says find the standard deviation. So we said the standard deviation is just the square root of the variance. Okay. So sigma is equal to the square root of the variance of x, which will give us the square root of 19 divided by 80. I will allow my answer as this, but if the question has told me to put my answer to a certain number of decimal places, then I will now punch and put my answer to that number of decimal places. But if not, I'll just allow my answer like this. Okay, so like I said, this part we are not going to touch it. Okay, we are not going to touch this part because we are still to do mean. It's just that it was part of the equation, so that's why I just copied it. Okay, so we are looking at the next example, still on the application of, still on exercising the mean and the variance on all the rest. So we are now going to further maths. Okay, the probability density, this is June 2013, paper 3, further maths. The probability density function of a continuous random variable y is given by this. Show that k is equal to 1 over 6 and evaluate the probability that the magnitude of y is less than 1. Okay, in fact, there's no even need to put solution. I just have to be solving under every equation. So how do I show that k is equal to 1 over 6? I also use the fact that since y is a continuous random variable and f is the probability density function of y, what happens? It implies that the integral, now you realize that there are two different bounds. Okay, so you are going to say, we are here instead. So we are going to take the integral from, what is the first bound? Negative 2 to where? To 0 of, integral from negative 2 to 0 of k into, of k into y plus 2, okay, dy. Then we add it to, because there's another portion, and that portion is the integral now from where? From 0 to 2 of 2k dy must be equal to 1. So I'm integrating f of y from negative 2 to 2. But now it is divided into negative 2 to 0, it is this function, and then 0 to 2, it is this function. Okay, so since y is a continuous random variable and f is the probability density function of y, then the integral from minus 2 to 2 of f of y plus the integral from, minus 2 to 0 of f of y plus the integral from 0 to 2 of the very f of y must be equal to 1. If you don't want to use this, you can use the fact that the function f is continuous. You can use the fact that f is continuous, and if it is continuous, it means that f is continuous on its domain, which means that it must be continuous at 0. So f is continuous at 0. Why are we saying so? Because the only relationship between the first bound and the second bound is the point y equal to 0. Okay, that's the only relationship. So since you have told that it's a probability density function of a continuous random variable, then the function itself has to be continuous. And if you're continuous at 0. And if you're continuous at 0, we just have to take the limit as x tends to 0 from below must be equal to the limit as x tends to 0 from above. Then we find the value of k. Okay, but anyways, let's just use the first part because I don't think the second part might really work. Anyways, let's just use our definition. Yes, let's use our definition. Okay, so here, what does this mean? So let's go gradually. Now k is a constant. I put it out of the integral, then I'll be integrating this function. Since k is a constant, put it out of the integral and remove it from here. And then now plus 2k is also a constant. Put it out of the integral and you'll be integrating dy. Okay, you'll be integrating dy and equate to 1. Okay, so this means that now let us integrate. So you have k. Now if you do the first one, what do we have? If you integrate y, you have y squared over 2. If you integrate 2, this 2 is the same as 2y to the power 0. Okay, so there's an invisible y to the power 0 there. So you put a 2 outside, you put y to the power 0 plus 1 over 0 plus 1, which is just y at the end of the day. And it is from negative 2. It's from negative 2 right up to 0. Okay, then plus 2k outside. Now having a 2k outside, if you integrate dy, like I said, there's an invisible y to the power 0 there. So if you integrate dy, we are just going to have y. Then we are integrating from here 0 to 2 and we equate everything to 1. Okay, so this means that let's fit our upper bounds and lower bounds and see what we get. So we have k. If I fit the upper bound, I get 0 squared over 2 plus 2 times 0 minus, let's fit the lower bound. If I fit the lower bound, I'm going to have negative 2 squared is the same as 2 squared, okay, divided by 2, then plus 2 times negative 2. So I feed the upper bound and I feed the lower bound. In fact, when I feed the upper bound, everything gives me 0, so I can just cancel it. Then remember, when we feed the upper bound, we need to subtract from the lower bound. Now when I feed the lower bound, I'll take negative 2 all squared is the same as 2 squared, which is 4. 4 divided by 2 is 2, so I have a 2 here. Okay, now I'm going to have here 2 times negative 2 becomes minus 4. So I'm going to have here 2 minus 4 is equal to, so what is inside here is going to be minus 2. Okay, minus 2. And there's a minus sign here because we are subtracting the lower bound. And that minus sign now makes everything to be positive. So this is just equal to 2k. Now plus 2k outside. If I fit 2, I get 2. If I fit 0, I get 0. So it's just 2. Then we equate everything to 1. So at the end of the day, you realize that we are going to have what? 2k plus 4k is equal to 6k. So 6k is equal to 1. Therefore, what is the value of k? K is equal to 1 over 6 as required. So take your time again and go through the steps, alright? Especially the simplification, because I think I was a little bit faster there. So just forget about this other part because it does not work all the time. Okay, now lastly, evaluate. We are asked to evaluate this probability. So what we do is that we first of all look for the range of values of y. Okay, we look for the range of values of y. So probability of, now the magnitude of y is less than 1. It means that by definition minus 1 is less than y less than 1. Okay, that's the definition. So let us recall. What do we need to recall? Because you see so many cases like this and you just have to apply this recall I'm giving you. So if you have the absolute value, or let me use a general case of a function. So if you have absolute value of h of x, you have the absolute value of h of x less than or equal to, or maybe only less than any of them, maybe less than a. Okay, this just means that minus a is less than h of x less than a. Then you now solve for x. So in this case, you see that my h is like capital Y and my a is 1. That's why I just deduced directly. Okay, so it therefore means that the probability of the absolute value of y less than 1 is the same as the probability of minus 1 less than y less than 1. And I gave you guys a definition at the beginning that the probability of a variable lying between alpha and beta is just the integral from alpha to beta. So this is going to give me the integral from minus 1 to 1 of f of y dy. Okay, that's the answer. Now let us get it. Now I have to come back to my interval. You see that from minus 1 to 1, the function has two different definitions because it first of all exists from minus 1 to 0. Minus 1 to 0 is inside here, okay, and then 0 to 1 is inside here. So I'm going to split with respect to the intervals that I have. So what I'm going to do is that I'm going to have the integral from minus 1 to 0 of f of y dy, then plus, now the next interval is now the interval from 0 to 1 of f of y dy. Okay, so this is going to give me, now in the interval minus 1 to 0, what is f of y? You see that in the interval minus 2 to 0, f of y is equal to this man. And since minus 1 to 0 is also inside here, it therefore means that the f of y we are going to use is k into y plus 2. So I'm just going to have here, let me just write integral from minus that to 0 of, in the place of that we need to have k into y plus 2. But what is k? K is 1 over 6, so I just remove it from the integral and put it out of the integral. Now in the interval 0 to 1, what is f of y? We come back. Oh, I've missed it. So 0 to 1 is inside here, okay, because this man ends at 2, so there's a 1 before the 2. So your f of y is equal to 2k. Okay, so there we are going to put plus the integral from 0 to 1 of 2k. So plus the integral from 0 to 1. In the place of this man, I need to put 2k. But 2k is a constant, you put it out of the integral. But what is k? K is 1 over 6. So you have 2 times 1 over 6. 2 times 1 over 6. Good. Now let us proceed with simplifying. So it therefore means that, therefore, the probability of the absolute value of y less than 1 is equal to, now here 1 over 6 is outside. Now let us integrate. If you integrate y, what do you have? Y squared over 2. If you integrate 2, you have 2y. Now we are from minus 1 to 0. Then plus 2 times 1 on 6 is 1 on 3. If you integrate dy, you just have y. Okay, if you integrate dy, you just have y. And then you are from 0 to 1. Okay, this time around you are from 0 to 1. So if you integrate that, you have y from 0 to 1. Now let us fit the upper bound. Let's start with the first one. So in the first one, 1 over 6 is common. Once I fit 0 here, everything is 0. Okay, so I have 0 minus. When I fit negative 1, let me open the bracket. When I fit negative 1, I'm going to have negative 1 squared, which is 1. So I'm going to have half there, plus 2 times negative 1 is negative 2, so it's minus 2. Okay, then now you see that half minus 2 is negative 3 on 2, so minus 3 on 2. But there's a minus outside there, so you have everything here equal to 3 over 2. Good. Now let us go to this man. To this man, we fit 1, you're just going to have 1/3 into, we fit 1, you have 1, you fit 0, you have 0, so just 1/3. Now if you simplify the first one, 3 here 1 time, 3 here 2 times, so that gives us 1/4 plus 1/3. Okay, so at the end of the day, we have 7 divided by 12. So in conclusion, we can conclude that therefore this probability is equal to 7 divided by 12. So that's a probability. Okay, now we need to determine the mode, the median, the upper and the lower quartile of a continuous random variable. So the mode is the value of x with the greatest probability, okay, which means we know that for a function to be for this, our f is a probability density function. For it to be maximum, then its derivative must be 0. So if they say find the mode, we have to differentiate our function and equate to 0 and find the value of x. That gives us the mode. Now what about the median? If m is a median, then the median is also called the interquartile range or the semi-quartile range, okay, and it is defined by the integral from the lower bound of the interval to m of the function must be equal to half. That's the median. What is the upper quartile? Because this median is like the probability is 50%. The upper quartile, the probability is 75%. That's why I see 3 on 4. So you are still integrating from A to U. And the lower quartile, for the lower quartile, the probability is 25%. That's why you are seeing 1 over 4. So these are just their definitions. Now let us look at this example, which is from June 2018 Statistics Paper 3. So it reads, a continuous random variable x has probability density function given by this. Calculate for this distribution the value of the constant k, the mean, the variance, and the mode. Okay, let us begin with the value of the constant k. So since it is a probability density function, what does it mean? The integral from 0 to 3 of f of x must be equal to 1. Okay, so there's no need for me to be writing all those long stuffs again. So the integral from 0 to 3 of f of x with respect to x must be equal to 1. So this means that the integral from 0 to 3 of k is a constant, so I can just put it out of k. Now I'm going to multiply each term here by x that is outside. So I'm going to have here 3x minus x squared dx. So this gives me equal to 1. Okay. So this means that we have k outside. Now let us integrate normally. So if I integrate the first one, I have 3x squared over 2 minus x cubed over 3. Okay. From 0 to 1 equal to 1. From 0 to 3 equal to 1. Okay, so this means that we know that when we fit the lower bound, which is 0, everything gives us 0. So we'll just focus on fitting the upper bound, which is 3. So you have k into. If I fit 3, I get here 3 multiplied with 3 squared and divide by 2 minus 3 cubed divided by 3 and equate to 1. So here we have to divide by 2, sorry, not by 3. So this means that we have k into. Now this is 3 times 3 squared is 3 cubed. So this is 3 cubed over 2 minus 3 cubed is 27, so I'll just put 27 here, 27. In fact, let me just put 3 cubed, okay, minus 3 cubed divided by 3 equal to 1. If I had a calculator, I'll just punch directly. But since I don't have a calculator, I want to be using. So I'm going to factorize 3 cubed. I'm going to have also k. I'm going to be left here with half minus 1/3, okay, equal to 1. And half minus 1/3 is 1 over 6. So at the end of the day, we have 3 cubed times k times 1 over 6 is equal to 1. So if I multiply both sides by 6, so k is going to give me 6. Then I will divide by the 3 cubed, which is 27. 3 can go up there 2 times, I can go down here 9 times. So I can conclude that therefore k is equal to 2 divided by 9. So that's the value of the constant k. Okay. Now what is the mean? E of x is equal to, from our definition, the integral from 0 to 3 of x times f of x dx. So you are going to have the integral from 0 to 3 of. Now, what is my f of x? There is a k outside, and my k, so let me put this man first of all. Okay, so you have x times f of x, but there's a k outside, and a k is 2 over 9. All right, so I think by dx, so this is going to give me 2 over 9 times, now let me multiply that x with every term. So if I remove the x from me, I'm going to have here 3x squared minus x cubed. I think you guys can be able to do this, so I'm just going to leave it. Okay, tell me the answer in the comment section. Now, what about the variance? So even for the variance, we know the formula. The variance of x is equal to e of x squared minus e of x all squared. Okay, now we know that e of x squared is equal to, by definition, the integral of x squared times f of x. Okay, so you are going to have the integral of x squared times f of x, but now there's a k which is 2 over 9. So this is what you have. So when you finish, you simplify this answer, you come and replace in this formula, and you have your answer of the variance. I think we have done many examples of mean and variance using integration. So I'm running to come to mode. So what is the mode? So if I say let x be the mode of capital X, what does this mean? This means that we have to solve the equation f prime of x equal to 0. So f prime of x is equal to 0. Okay, so my f of x, according to what I have, is equal to, where's our f of x? We come back here, this is the f of x. Okay, so I'm just going to differentiate, equate to 0, and find the value of x. That value of x is my mode. So this is my f of x, but what is k? K is 2 over 9. Okay, so I'm just going to put 2 over 9. I'll multiply every term by x, so I have 3x minus x squared, so that I can easily differentiate. I'm just running away from product rule. Okay, so if you get the derivative, f prime of x is equal to 2 over 9 is a constant, so it stays out. If we differentiate 3x, we have 3. Okay, if we differentiate x squared, we have 2x, so minus 2x equal to 0. Sorry. So f prime of x equal to 0, what does it mean? It means that we have 2 over 9 into 3 minus 2x is equal to 0. So from here, x will be equal to 3 divided by 2, 1.5. Alright, so my mode is 1.5. So for x equal to 1.5, my probability is maximum. We can even try. Okay, we can even try. So if you solve this man equal to 0, you're going to have x equal to 1.5. So that is my mode of the continuous random variable x. Okay, so this was, which year was this? It was Statistics 2018 paper 3. Now I think here is, we'll have two more examples to go. Then we talk about cumulative distribution function. So we now have this next example. I'm just going to push it down. Okay, I'm just going to push it down so that we have a better experience. So this is June 2019 Math with Statistics paper 3. You see here they're talking about the mean, so I want to do it. So the probability density function f of a random variable x is given by this. Calculate the value of a constant k. Like we said, there is no need for us to be writing the history again, but in the exam you must write the history that since x is a continuous random variable and f is the probability density function, then the integral of, but I'm just going to write it to save time. So the integral from minus 3 to 3 of f of x dx must be equal to 1. This means that we have the integral from minus 3 to 3, what is f of x? It is k into x plus 3 dx must be equal to 1. K is a constant, so I'll peacefully put it out of the integral. Then I'm going to integrate normally. Okay, so let us integrate normally. So you put k out of the integral. Now if you integrate, let's just equate to 1. So if I integrate x, I get x squared on 2. If I integrate 3, I get 3x. Okay, this is from minus 3 to 3. From minus 3 to 3. Okay, so let us fit the upper bound first. If I fit the upper bound, I get 3 squared over 2 plus 3 times 3. That's what I get. Minus, we now need to fit the lower bound. If we fit the first lower bound, it is minus 3 squared. It's minus 3 all squared, which is also 3 squared. So we are going to have 3 squared over 2. Then if we fit, we are going to have 3 times minus 3, which is minus 9. Okay, so we have minus 9 there. And then we equate everything to 1. So at the end of the day, what do we have? Let us simplify. So we have k into. Now let us simplify and see. 3 squared on 2 minus 3 squared on 2, 0. 9 minus negative 9 is 9 plus 9, which is 18. So it means that what is the value of k? K is equal to 1 divided by 18. Okay, so k is equal to 1 divided by 18. Now the expected value is the mean. Like I told you guys, the mean is also called the expectancy of x, or the expected value. So the mean of x by definition is equal to what? The integral from minus 3 to 3 of x times f of x dx, which is equal to, by definition, the integral from minus 3 to 3 of, I'll put the x outside. What is our f of x? It is k into x plus 3. So I'll put a k outside, 1 over 18. Then I'm going to put the x plus 3 inside, x plus 3 dx. So this gives me 1 over 18 times the integral from minus 3 to 3. I'll multiply every term by x, so I get x squared plus 3x dx. Okay, so this means that my expected value is 1 over 18. Now let us integrate separately. Okay, so if I integrate the first term, I get x cubed on 3. Integrate the second term, I get 3x squared on 2. This is from minus 3. This is from minus 3 to 3. So you are going to have 1 over 18. But I think also do this one and tell me your answer in the comment section, or you get to me on WhatsApp. Okay, now what is the probability of 0 less than x less than 2? By definition, we said it is the integral from 0 to 2 of f of x dx. Okay, so this is equal to the integral from 0 to 2. What is our f of x? It is k into x plus 3. So 1 over 18 into x plus 3 dx. Okay, so this gives me 1 over 18. Now I think if we integrate x plus 3, we have the answer already, right? The answer is x squared plus 3x. We'll just have to change by the boundaries this time around. So you have x squared plus 3x, but here we are moving from 0 and we are arriving at 2. So in conclusion, what do we mean? We mean that probability of 0 less than x less than 2 is equal to 1 over 18. This one is nice because if we fit 0 here, we have 0. So we just fit 2. So we have 2 squared on 2 plus 3 times 2, which gives me 1 over 18 into 2 squared on 2 is like 4 on 2, which is 2. And 2 plus 6 is 8. So you are going to have 8 over 18. And 8 over 18, 2 goes there 4 times and goes there 9 times. So that is my probability. Okay, then the last part says that if the median of x is m, show that m satisfies this equation. So from our definition, we know that if m is a median, what happens? The probability is equal to half, right? The probability from the lower bound. The lower bound is negative 3. So the integral from negative 3 to m of f of x dx is equal to half. Okay, that's the definition. If it's the upper quartile, then we will replace this man with u and we equate it to 75%, which is 3 over 4. If it's the lower quartile, we replace this one with L and equate it to 25%, which is 1 on 4. So this means that we just have, now we already know the answer. Do we know the answer? Yes, we know the answer. We know the answer of integrating f of x. So what changes is just a bounds. Okay, here is the integral of f of x. So what is changing is just a bound, because we already know it from here. So we are just changing with the bounds. So we have the same answer, but now we are integrating from minus 3 to m. Then we equate the result to half. Okay, so what happens is that left hand side is 1 over 18. 1 over 18. Now let me fit m. I'm going to have m squared on 2. M squared on 2 plus 3m minus. Now let us fit the lower bound. Minus 3 all squared on 2 is 9 over 2. Okay. Then 3 times minus 3 is minus 9. So you have minus 9. So that's my lower bound. And equate everything to half. Now 9 minus 9 over 2 is equal to negative 9 over 2. So this man is negative 9 over 2. But because of this positive sign, everything becomes positive 9 over 2. Good. Now I'm going to multiply all through by 18. Okay. So I'm going to multiply 18 on the left hand side. So I'm going to take 18 times everything here, which means it's the same thing I'm going to do the right hand side. 18 times everything here. Okay. If you do that, the 18 that is here cancels the 18 that is here. We are just left with what is inside here. Okay, we are left with this. Then equal to 18 divided by 2 is 9. Now what's the next thing to do? We multiply all through by 2. So I take 2 times everything on the left hand side. Okay, equal to 2 times everything on the right hand side. So if I do that, you realize that 2 multiplied by m squared on 2 is 2 multiplied by m squared on 2 gives us m squared. Okay. Next, 2 multiplied by 3m gives us 6m. Okay. So you have m squared plus 6m. Then 2 multiplied by 9 over 2 is 9 plus 9 equal to 18. So this means that I'll subtract 18 on both sides. So m squared plus 6m. 9 minus 18 is minus 9 equal to 0. So m squared plus 6m minus 9 is equal to 0. So there's a typing error here. It's supposed to be m squared, not m cubed. So that is the proof as required. You can now be asked to find m. You see that you just solve this quadratic equation and get the value of m. M will be equal to 3. M equal to 3. Yeah, m equal to 3. Wait. If you solve this, yes, m will be equal to 3, which means the Bayesian is 3. I don't know if I made a mistake somewhere. I don't know if you have made a mistake somewhere. But you guys should just verify, okay? Just try to verify. And you let me know, okay? Verify and let me know. Okay. Now let's go to determine the cumulative distribution function. Cumulative distribution function of a continuous random variable. So this is a definition of cumulative distribution function. F of x is equal to the integral from minus infinity to infinity of the probability density function. Now, to explain, I'll just use this example, which is actually our last example, which is Further Maths Paper 3, June 2015. That was where I could easily find it. Okay, so we have a random variable x has probability density function given by this. Find the value of lambda. Then just push it down so that we have a better experience. So find the value of lambda. So we just have to integrate from 0 to 1 of this function and equate it to 1. Okay, then we get lambda. So the integral from 0 to 1 of lambda into 1 minus x squared is the x is equal to 1. This means that lambda is a constant outside. Now let us integrate 1, we get x, integrate x squared, we get x cubed on 3. Okay, x cubed on 3 from 0 to 1 equal to 1. So this means that we have lambda into what is you are going to have 1 here, 1 minus 1 third is 2 third equal to 1. So what's the value of lambda? 3 over 2. So lambda is equal to 3 divided by 2. Okay, hence determine the mean and the variance. There's no need for me to do that. You can look it as an assignment. I'm going to do C and D. Okay, now how do I get a cumulative distribution of f? So I'm going to call it capital F of x equal to, so my capital F of x is equal to, because my this thing is f. If it was g, I'm going to call it g of x. Okay, capital G of x. So what I do is, first of all, let us try to analyze the intervals given to us. Okay, now the interval I have here is from 0 to 1. Okay, so let me just try to indicate something on the number line. So on the number line, this is a real number line. So here's my real number line. Okay, now we need to indicate 0 to 1. So we have the first one, which is 0. First one is 0, and then second one is 1. All right, so we have 0 to 1. Okay, good. So I have 0 to 1. Okay, now you see that since my f of x is the integral from minus infinity to infinity, that is why I started by drawing a real number line, because it has from minus infinity to infinity. Okay, now we see that we can easily identify 3 different intervals on this number line. The first interval is this interval here, that is from minus infinity to 0. The next interval is from 0 to 1, and the last interval is from 1 to plus infinity. So what I'm going to do is that I'm going to find my capital F of x in each of those intervals. Okay, so first interval is for x less than 0. Okay, for x less than 0, because if you are from minus infinity to 0, you are less than 0. So my f of x in this case will be equal to, now whenever you say x is in this interval, okay, what you try to do is that just try to imagine that we have a certain point x that is in that interval. So let me just say I have an x that is there. All right, so I have an x that is there. So if I have an x that is here, okay, what I do is that I'm going to integrate from the lower bound of that interval to x. So from minus infinity right up till the x, okay, of my small f of x dx. So that's what I do. Okay, so integral from minus infinity to this x of f of x. But we know that according to the definition of my f of x, when they say this otherwise means that x is less than 0 union x is greater than 1. Because according to what we have here, we have x less than 0, we have x greater than 1, and then we have x between 0 and 1. So this capital F of x is equal to 0 in it was written there otherwise, which means that in the remaining intervals. Okay, so if I integrate it from minus infinity to x, you see that we are with x less than 0, and the f of x there is just equal to 0. So when we integrate 0, we just have 0. Okay, so that's the first interval. Now the next interval is from 0 to 1. So 0 less than or equal to x less than or equal to 1. That's my next interval. So what is my capital F of x? Like I said, I'm going to change now the position. So my x is here. Okay, so what I do is that since it is cumulative, I'm going to integrate. What I'm going to do is that I'm going to integrate from minus infinity to 0. Okay, that's I first of all integrate in this interval. Then later I add it to and now integrate from the 0 to x. So I integrate from minus infinity to 0 because I have to consider this first part. Then in this next part now, I'm now integrating from where? From the lower bound to where the x is placed. Okay, so now we know that the first answer here is just the answer we got above, which is 0. Now plus the integral from 0 to x of f of x. Now what is f of x? If I'm integrating from 0 to x, you see that normally this my x here is the interval 0 to 1. And when x is in the interval 0 to 1, the f of x is lambda into 1 minus x squared. Okay, and we already have lambda as 3 on 2. So I'm going to put 3 over 2 outside here into 1 minus x squared. Now let us get the answer. So we have 3 on 2. Now we are going to have, if you integrate x, you have 1, you have x minus x cubed on 3 from 0 to x. You realize that if you fit x, you just have the same answer here. Where you fit 0, you have 0. So the final answer, so I can say therefore my capital F of x on that interval is just equal to 3 over 2 into x minus x cubed on 3. Why? Because when I fit x, it does not change, it still remains as x. Then minus, when I fit 0, I get 0. So this is my f of x on that interval. Now finally, then the last interval is x greater than 1. Okay, x greater than 1. Now what is our capital F of x? What is our capital F of x in that interval x greater than 1? So I come again and I change the position of x. So this is where x is. Okay, so what I'm going to do is that I'm going to take integral from minus infinity to 0 plus integral from 0 to 1 plus integral from 1 to x. So I have to consider all the intervals behind. So I'm going to have integral from minus infinity to 0, okay, plus integral from 0 to 1, then plus integral from 1 to x. That is it. Now this answer is 0. This answer is 1. It's a definition. If you check the beginning, you see that the integral of it is always 1 in that interval. Okay, so this answer is 0, this answer is 1. So you have here 0 plus 1. Now you see that in the interval x greater than 1, your f of x is 0 according to the definition that we have here. For x greater than 1, f of x is 0, and when we integrate, we get 0. So you are going to add plus 0. And the final answer gives me 1. Okay, so we are now going to write our function. So our capital F of x will be equal to, so it has 3 different intervals. So the first answer is for x less than 0, and the result is 0. So we have 0 comma, so we have 0 for x less than 0. Now the second answer is this man where x is between 0 and 1. So we have this guy for x 0 less than or equal to x less than or equal to 1, and the last man is equal to 1. Okay, the last man is equal to 1, and in this case x is greater than 1. Good. So this is my cumulative distribution function. If they now give you that, okay, get the probability density function from this cumulative distribution function, what do? What you do is that this small f of x is just the derivative of capital F of x. Okay, so you just have to differentiate. That's the definition. Since the capital F of x is the integral of small f of x becomes a derivative of capital F of x. So what we are going to do is that we are going to differentiate. So when we differentiate 0, we have 0. So the answer gives us 0 for x less than 0. So we have here 0 for x less than 0. Now if we differentiate this man here, we are going to have 3 over 2 into 1 minus, if I differentiate x cubed on 3, I get 3x squared on 3, which is x squared. Okay, and the interval is 0 less than or equal to x less than or equal to 1. And finally, if I differentiate 1, I get 0, and this is for x greater than 1. So you clearly see that when x is less than 0 and x is greater than 1, our small f of x is equal to 0. And then when x is between 0 and 1, we are going to have what? This answer, which clearly gives us back the original definition, because our lambda is equal to 3 on 2. So you see that when x is less than 0 and greater than 1, the result is 0 for f of x. And when x is in this interval, this is the result. So that's how we can move from cumulative from cumulative back to the probability density function. Okay, so for this last part, we first of all need to solve this inequality. Remember that this mu here is the mean and sigma is the standard deviation. Okay, so you need to first of all find the standard deviation, and to get the standard deviation you must find the variance. So you must solve the second part, but let me just try to indicate to you guys what to do. So we first of all need to solve this inequality and get the range of values of x. Okay, so like I told you guys that if the absolute value of a function is less than another, what does this mean? This means that this function inside here, x minus mu, is less than sigma and it is greater than negative sigma, less than or equal to here, and the same thing here. So that is it. So for me to get x, I'll need to add mu on both sides. Mu is the mean, so I'm going to have sigma plus mu less than x less than sigma plus mu. So the probability in question less than or equal to sigma. So the probability they are asking us to find is just equal to the integral, because it's a continuous random variable. So the integral from the lower bound, this is the lower bound. Normally when you have the values, you just have to fit there and simplify to the upper bound. Here's the upper bound of f of x dx, and it gives you the answer. Okay guys, we have come to the end of our lesson. I'm already tired, so I cannot really introduce the next topic, our next live session, but it's going to be next week Sunday. Okay, it's going to be next week Sunday. We are going to be looking at discrete random variables alongside probability distributions, where we look at binomial distribution, Poisson distribution, normal distribution, uniform or rectangular distribution, geometric distribution, exponential distribution, and Bernoulli distribution. We look at all of them because they are in the syllabus of both further maths and Matthew statistics. So for your assignment, you are going to check all the questions we have not done in this video in math. So for math statistics students, your assignment is that you check from June 2000 to June 2024. All the questions you have not solved, you solve it under continuous random variable. Okay, then for further math student, the same thing, from June 2000 to June 2024. All the questions you have not solved under continuous random variable. Once you see a question, you just tackle it. Okay, so I think we can end here for today. Thank you guys for sticking to the end. See you guys next week Sunday for another live session.